Hello and welcome to Snapcraft Office Hours number 5. I'm Alan Pope and I work on the Snappy team at Canonical. We're doing a slightly different office hours this week. Usually I'm joined by a bunch of my colleagues. Unfortunately, they're all at events. Some of them are away at UbuCon, which is in Lima in Peru, and others are at an event in the UK. So I'm afraid you just got me this week. And we're going to do something slightly different in that I want to give a bit of a tutorial on a particular subject that I find interesting. You may find interesting as well. Before we get started with that, a little bit of admin. We do these usually every other Friday, but we're going to be doing a few in a row because people were out this week. We're going to get them in next week. So you're going to have a few of these in succession with different interesting topics. You can find us on a number of places online. You can find us on YouTube, obviously, the Snapcraft IO channel. You'll find on YouTube has all of our past videos, and you can subscribe there and get notifications when the next video comes out. We're also on Twitter. You'll find us on twitter.com/snapcraftio, and we're also on Google plus Snapcraft.io there. We also have a Rocket Chat channel where we hang out. So you'll find the Snapcraft and Snappy developers hang out in there on Rocket Chat. So if you want to ask any technical questions, you can ask them in there, and the team hang out in there. Today might be a bad day for that because, as I say, a bunch of them are away at events. But typically we hang out in there. We also have a forum. If you go to forum.snapcraft.io, that's better for long form conversations, detailed threads about whatever topic takes your mind, whether you're having problems with something to do with Snapcraft or Snappy. That's a good place to go. So this week I wanted to cover something that I've been doing a lot recently, and I think might be useful information to some of you, and that is to build within containers. So typically when you're running Snapcraft, if you run Snapcraft on your local machine, whether you're running Ubuntu 16.04 or another release, you're building actually on your local machine. And there's a few disadvantages to that, and I'll cover those in a minute. But before I start, what I want to do is get my laptop ready to do the demos and tutorials. So I'm going to paste a command in here, and all it's going to do is install the necessary parts that I need. So I'm installing LexD client and Snapcraft on this laptop. Away it goes. So while that's all installing, I'll explain why I'm doing this. So what I want to be able to do is build in inside a virtual machine kind of thing inside a container that will ensure that the Snap that I'm building doesn't get tainted with anything that's on my machine. I want to build somewhere completely clean, and that's what I'm building using LexD. The benefit of this is that Snap, when the Snap comes to be installed on an end user machine, the version that I'm building against, which is 16.04 Xenial, will match more closely what will be on the end user's machine. Even if the end user is on Fedora or Solus or OpenSUSE, the Ubuntu core image is based on Ubuntu 16.04. And so if I build for 16.04 on 16.04, then I'm more likely to have success when the Snap is installed on an end user machine. So the other thing that I want to do is not pollute the Snap with stuff that I may have on my laptop. So on my laptop, I might have PPAs enabled. I might have all kinds of different versions of wacky things on my laptop, and I don't want to pollute the Snap with any of those things that might be on my machine. So I want to basically build in a clean environment. I also want the build to be reproducible so that I can rerun Snapcraft both on my local machine and on remote machines, and know that the build behavior will be the same on here as it is on another machine. What else? Oh, also, something we might try and cover towards the end is building on a remote machine that may be faster than my laptop. And building in LexD is really easy to do on a remote machine. So, for example, I've got a fairly low power, low spec laptop, but I've got another machine which is a lot more powerful, and I may want to do the build over there, especially for something big and chunky, like, if you're building a snap of LibreOffice or Firefox or something else, pretty chunky, big desktop application, you might want to build it somewhere else, or even on a server somewhere, and I'll talk more about that as well. So what I want to show is building inside LexD, building on remote hosts, and maybe building on a different architecture as well. We shall see if we get time for that. So all I've done so far is just install LexD, LexD client, and Snapcraft on this machine. Now this laptop happens to be running Ubuntu Artful, so it's the development release of Ubuntu, which will become 17.10. So there's another good reason why I want to build inside a clean container, because this is 17.10 and not 16.04, which is what Ubuntu Core is based on. So now I've installed LexD. What I want to do is set up LexD, and that's pretty easy. I just run sudo LexD init, and when I do that, it's going to ask a bunch of questions, and I'm actually just going to take all the defaults. There's plenty of documentation around LexD to uncover what all of these options mean. This particular option here I'm going to come back to a little bit later. Would you like LexD available over the network? We'll talk more about that a bit later, but I'm just going to take the default no for now and just accept all of these defaults. Done. So LexD is now set up, and I can prove that LexD is set up correctly because I can actually launch a container just to prove it. So if I just do lxc launch Ubuntu 16.04, it will go off and get an image of Ubuntu and then launch that on this local laptop. Now, you don't really have to do this because the LexD setup is pretty robust, and just doing LexD in it should be enough. But I just wanted to do this just to illustrate that we can prove that LexD is all set up correctly, and it's pretty easy to do. So I just do lexc launch Ubuntu 16.04, and it goes off and gets an image. Now it'll cache that locally, so the next image that it builds, it will do a lot faster because it will keep this root file system on the local machine, and then the subsequent machines it builds, it will just effectively clone. So it's done. If I do lxc list, I can now see a list of machines, and there is only one. It's got a generated name. Intimate Gibbon. Brilliant. And I can actually jump into it. If I do lxc exec and just tab complete the name of it and do bash, then I'll end up with a bash inside that machine. I wonder if lsb release works. So there you can see that's a 16.04 lexc image. So that worked perfectly. I'm happy that lexc is set up, and I can stop that image. If I just do lexc stop and then the image name, or the machine name rather, now that I've stopped it, if I do lexc list, it's stopped, and now if I do lexc delete, it'll go away. And now if I do lexc list, there are none. So now I've proved that lexc is all installed correctly, LXD is all installed correctly, and it all creates successfully. Now what I really want to do is use this for Snapcraft. So I want to build something inside a container. Now, Snapcraft has a tour, a very quick and easy way to learn how to use Snapcraft. So if I just run Snapcraft tour, what it will do is create a directory called Snapcraft tour. And in there's a whole bunch of examples. Let's pick the easiest example, Easy Start. And what you get in here is a tiny little YAML file, which you can see there. It's just a hello world, my first snap kind of thing. And if I were to run Snapcraft now, like that, it would start Snapcraft and it would start building this snap on the local machine, which is running 17.10. But I don't want to do that. I want to build it inside LXD. And the way you do that is you do clean build. So if I do Snapcraft clean build, it will then create a new LXD container into which it will then copy the Snapcraft YAML and any other assets, because your snap maybe consists of not just a YAML, but there could be zip files and desktop files and icons and images and all kinds of other assets. And what Snapcraft will do is package all of that up, zip it all up, and then put that inside the LexD container. It's now setting up the environment inside the LexD container. Yep, and it's doing all the setup, ready to start building the Hello World application. So if I were to run LexC list now, which I can do with, if I split the screen like this and we do LexC list, there we go. You can see my container is there running, and I could jump into it and have a poke around, but by the time I do that, actually, it will probably be deleted by by Snapcraft, because as you see, it's now finished. So what it's done at the very end there, it says it's snapped Hello World, this hello program, and then after it's finished building the snap, it pulls the snap outside. So the retrieved bit is it pulls it out of the LexD container and then throws the LexD container away. So if I do LexC list again, it's gone. So it's ephemeral. It's only created for the purposes of doing the build, and then it's thrown away afterwards. So that's cool. I've now got a snap that was built inside LexD, built on effectively on 1604, which is brilliant. That's exactly what I want to do. So actually, that's how I always build snaps now. Even though I have various machines which are 1604 or 1710 or whatever, I always build them with Snapcraft Clean Build, because then that ensures that it builds inside the right version of Ubuntu, ready for uploading to the store and distributing to users. So let's move on to another cool example. So I said that it's possible to access LexD remotely, and accessing LexD remotely is really easy and also built into Snapcraft as well. So I can use Snapcraft Clean Build to build on this machine, but there's also an option to build on another machine. And the way you set that up is well documented, and actually I'll show you the documentation, because it's pretty good. If you're interested in anything LexD, Stefan Graver's website is where you find loads of information. He's written loads of blog posts about LexD. This particular article about LexD remote host, if you just use your search engine to search for LexD remote host, you'll find this post. And in here it talks about why you want to do this and how you set it up, and it gives you the commands in the middle of the page to tell you exactly what to do. So that's all I'm going to do, is run these commands in order to expose the LexD that I've installed to the network. So let's grab the command from the web page, and if I do LexC config set, this will enable the network, and then the next thing I need to do is give it a password. So this will mean that I can't have I don't want random drive-by people connecting to my LexD daemon and spinning up machines on my host. So I'm going to put a password on there to secure it, and I'm just going to use the password Snapcraft for now, because I'm going to throw this away afterwards, so that's okay. So that's set up. So now I could remotely connect to that machine and have Snapcraft build on that machine. But what you need to do is register that remote machine in Snapcraft. So the way you do that is you do on another machine that you want to remotely access LexD, you do LXC remote add and then give it a name. So I've got another machine which is quite powerful, which I'm going to call Monster, and the IP address that it's on, or the host name. Right. So what this is going to allow me to do is on this laptop connect to another machine which I'm calling Monster because it's quite powerful. And this is registering the name of that system on my local host. And it asks for the password, and I think I know the password for that. There we go, done. So now I have a machine called Monster known to my laptop, and I can do clean build on that remote machine. So if I just do Snapcraft on its own, it builds locally. If I do Snapcraft clean build, it'll build inside LexD locally. But if I do Snapcraft clean build -- remote, and then the name of the machine that I registered, which in this case is Monster, it's now going to connect to the other machine, spin up a container, and then send all the compressed assets and the YAML file. In this case, it's a very small project, so there's not a lot to send over the network. But it'll send it all over the network to the remote machine. The build will happen remotely, and then when it's finished building, you can it will pull the built snap back down to the local machine. Now, typically that just works. There is actually an option for Snapcraft called debug. You can do --debug, and if you do --debug, then in the event that the build fails, it will actually leave you inside the container, and you can use shell commands to try and debug and diagnose why the build failed. So there is a way that you can leave the container up and jump into it in order to debug it. Right, so that's now finished. So that's built on a remote machine, and then the result brought down to my machine. Perfect. That's great. There's another interesting thing you can do with this as well. I was building locally. If you look at the architecture of my system, it's a x86 64 AMD 64 host, and the other host, Monster, the powerful laptop, is also an AMD 64 machine. But what if I wanted to build a snap which was for a different architecture? Let's say, for example, I wanted to build a snap for a Raspberry Pi. Well, what I could do there is build on a remote host, which is ARMHF architecture. And I happen to have one of those handy. So if we SSH to Ubuntu at another machine on my network, this is a Raspberry Pi. And so you can see there, it's a Raspberry Pi ARM v7. And so I could install LexD on this and set up LexD for remote access exactly the same way as described on Stefan's blog and the way I did just now, so that I could remotely build on a Raspberry Pi. Let's try it. So I've already set it up remotely, and I can do the same LexC remote add, but this time what I'll do is I'll add Raspberry Pi as the name and put in the IP address, which was different. It was 82, I think. Oops. And again, it's going to register that remote machine on my local machine, and I type in the password that I did when I set up remote LexD on that machine. There we go. So I can now do Snapcraft to build, if I could spell, Snapcraft to build locally, Snapcraft clean build to build locally inside LexD, Snapcraft clean build -- remote to build on a remote machine, and the remote machine is Raspberry Pi. But I need to specify that it's a different architecture. So I say target arch equals ARMHF. And when I do that, what it should do is connect to the Raspberry Pi. You can see there it says setting machine, target machine to ARMHF. So I'm currently sat on an AMD 64, 64-bit Intel machine. Now it's connecting to the Raspberry Pi, and LexD is downloading the rootfs image for an ARMHF build of Ubuntu that it's then going to spin up as a container. Snapcraft is then going to copy all the stuff across to the Raspberry Pi and then start building over there. I might well, actually what we could do is we can SSH over there again. So if we SSH to the remote machine, Ubuntu at that machine, so this machine is the Raspberry Pi that I'm SSHing into, and I think, have I got, if I do LXC list, there you can see it's still downloading the rootfs image, so it hasn't actually finished starting the LexC container, but it is doing that. You can see the name matches the name, the bizarre naming system that we use, a generated naming Snapcraft namely aware kit, apparently. If I LXC list again, it's probably, yeah, it's still starting up. But yeah, my Raspberry Pi is not the fastest thing in the world, so it's currently busily sitting away. But it will eventually spin up that LexC container and start building. taking a little while, unfortunately. I think it's working. That will take a little while. Cool. Yep, there we go. Now it's starting the LXD container, and then it will start doing the build exactly as it did. So now I've got to the state where I can build either, I can do quick builds on my local machine using clean build, or even faster builds on a remote faster machine. Now the remote faster machine in this case happens to be a desktop class laptop, a decent spec laptop, but it could easily be a remote machine like DigitalOcean Droplet or some other VPS provider or some server on your own infrastructure. You don't have to build on someone else's machine. You could build on, just a machine in your data center, you end up with the build being done remotely and all the resources cleaned up afterwards, and then the snap coming down to your local machine. Excellent. That's it. All done. It's building away. And you can also build for different architecture. Now, in this case, I built for ARM-HF to show you an extreme example of building on AMD 64 and ARM-HF, but you could build on i386 as well. It doesn't have to be that extreme AMD 64, completely different architecture. You could build on 32-bit Intel as well. So there was one other thing I wanted to show, and I'll leave that thing running for now. While that's running, we'll start something else. Now, the other thing I wanted to do is, if you're building something over and over and over again, you're iterating on a snap, and you're building the same, you keep doing a Snapcraft clean build, you'll notice what it's doing right now is it goes and gets a bunch of debs which are part of the build process. And that can slow down your build process because it's having to go and get all those debs every time from the archive. Now, what would improve things here is if we cached those locally. And so there's a way we can do that with a couple of easy steps. So what we can use is there's a package in Ubuntu called Squid Deb Proxy, and we can install Squid Deb Proxy, and then we can tell LXD to use that proxy, so that whenever we're doing a build within LXD, it doesn't go and get all the debs from the archive every single time. It will get them from the cache if they've been downloaded recently. So the way we do that is I need to install Squid Deb Proxy first. So I'm going to do this on my laptop while the build is happening remotely. So I'm going to do sudo apt install Squid Deb Proxy. Now there's a few steps to this. I want to install Squid Deb Proxy, but by default LXD won't know that there's a proxy on the outside of LXD. So I need to tell LXD how to contact the Squid Deb Proxy. The other thing that I need to do is I need to tell Squid Deb Proxy to allow it to access all the remote hosts that LXD might ever want to use. And the config file for that lives in etc Squid Deb Proxy, and it's called mirror dstdomain.acl. And I've taken a copy of it with my modifications. Actually, it's root owned, so let me just do this. Mirror dot, what did I say it was called? Mirror. That's it. And these extra lines here are the hosts that my LXD might want to connect to in order to build something. So some of these are needed for downloading parts for LXD itself, like the cloud images. Some of it's needed, like start.ubuntu.com is needed for the internet connectivity check that it does. It uses that to test whether the internet's working. The others are used when they're downloading parts from the Snap store. So, for example, when you're building certain types of snaps, it has to download other snaps from the store to do that build. The others are CDNs, GitHub if it goes and gets parts from GitHub, and there's also a subdomain parts.snapcraft.io where it gets parts from as well, and then Launchpad PPA. So there's lots of places where LXD might want to go and get packages from. So we add these into the config file. So all I'm going to do is just sudo cp that file into etc Squid Deb Proxy, and it will just replace the one that was already there, which is the same but without those 7 or 8 lines. What I also need to do is restart Squid Dev Proxy now that I've made that change. So I'm going to do sudo service Squid Dev Proxy restart. So what I've done now is I've installed Squid Dev Proxy. I've configured the proxy to allow it to connect to all these remote places that LexD might ever want to connect to when it's running Snapcraft. And then the final thing that I need to do is tell LexD on my machine how to get to that proxy, which is going to take just a minute while it's restarting Squid Dev Proxy. I'm not quite sure why it takes so long to restart, but it always takes a little while to restart on my laptop. Meanwhile, the Raspberry Pi is still building. It's probably getting a little bit warm over there. So if there's a couple of things I need to do here. When you install LexD, it sets up a bridged network device between the containers and your local machine. And that's how LexD will see the Squid Dev proxy. In fact, if I do IP address show, you can see it's right there, the fourth interface there, LXD-BR0. It's a bridge between the LexD containers and my network on my laptop. So what I'm going to do is extract that IP address with a bit of magic shell script. One line that just goes and gets the IP address for that bridge, which is, in this case, 10.113 something. And if we show that, LXD, whoops, can't type. You can see it's 10.113.129.1. And what I need to do is tell LexD that's how you access the proxy that's on the machine. So all I'm going to do is paste a bit of magic in again. And all this is going to do is feed that configuration into LexD. So now the next time I build something on this laptop, it's going to use the proxy, which is installed on my local machine, and I can test that. But we'll test that in just a moment. Let's close that window, and you'll notice now the Raspberry Pi has finished. So now I've got two snaps. I've got the AMD 64 snap that was built on my local machine, and I've got an ARM HF snap that was built on the remote machine. Winner. So now let's try building something a bit bigger, which will go and get more things from the archive so that we can check that it's using the proxy. So there's something a little bit larger in here. Yeah, this one here is going to need to go and get some cute packages and some other bits and bobs from the archive. So this will take a bit longer. So I'm going to run this again with Snapcraft clean build on the local machine. But this time what should happen is it should go and go via Squid Dev Proxy to go and get the packages. So what I'll do is split the screen, and what we'll do is sudo tail the log file for Squid Dev Proxy, access.log. Just to, I didn't do -f, did I? So we'll tail the access log just to make sure that it is going to do it. We'll switch back to the top one, and when I do Snapcraft clean build now, in theory, it'll start up a LexD container, and then it should start setting things up. And when it starts going looking for packages and things, we should see it. There we go. So now in the top half of the screen, what you're seeing is the usual apt update and apt-get install, a whole bunch of dependencies that are needed to build this thing. And in the bottom, you're seeing the Squid Dev proxy logs, where it's going and getting all the stuff from the proxy, which means the build is much faster. How cool is that? So if I were to time this, like before I added the proxy and then after I added the proxy, what you should see is a difference. How much of a difference really depends on how much time your project spends building and how much time it spends accessing the network. So for my colleagues over in South America who have pretty terrible internet connections in their houses, when they're building, they appreciate using a proxy. Whereas for me, going and getting the packages is a smaller proportion of the overall build time, so it doesn't affect me quite so much. But it's still quite useful, especially if you're doing it over and over and over again. The using the proxy is a nice way to speed things up. So yeah, that's working perfectly. Brilliant. So to wrap up, there's a few things there. You can use Snapcraft Clean Build with LexD in order to build locally inside a clean machine that's using Xenial, which matches the Ubuntu core version of all the libraries and things that the end user will run your Snap against. You can use Clean Build Remote in order to build on another machine, which may be faster or a different architecture. So in this case, I built on a bigger laptop, but I also built on a Raspberry Pi as well. And the Target Arch option lets you build for different architectures, and then using something like Squid Proxy means that it can go faster. In fact, it's just finished. So there you can see the Snap has finished building, which is rather groovy. Now, what you could do is do all of that, or there's another option. You could use this. You could go through all of that, or you could just use build.snapcraft.io. Build.snapcraft.io is a service that we provide, a free service that will build your software for you for AMD 64 and ARM HF and automatically push to the store every time you commit to your master branch. So if you just go to build.snapcraft.io and click the setup in minutes, it will allow you to log into GitHub, authenticate against GitHub, and then you tell it which projects on your GitHub library you want to build. Build.snapcraft.io will then allow you to register that snap in the store, build it, and then every time you make a change, it will rebuild it and push a new update to the store. It's a really super cool service. I strongly recommend you try that because it alleviates you having to build locally. You can still build locally if you want to, obviously, but building on build.snapcraft is just, easier. You just push to GitHub and it builds for you, and you get an email once it's finished building, or you can log into the store and check the builds, and you can check the logs within build.snapcraft.io as well. So I think that's everything I wanted to cover. We're under time, so that's good. So if you have any questions, the best place to get in contact with everyone is, as always, on our Rocket chat, which you'll find under rocket.ubuntu.com in the Snapcraft channel. And as I've mentioned before, the forums, forum.snapcraft.io is a great place to go if you get any questions, if you get stuck with any of this. You'll find everything you need to know on the forum. We've also got the Snapcraft docs, which are at snapcraft.io/docs, and there's all the documentation in there as well. But if you get any questions, you can ping me as well. I'm Popey in most of those places, on the forum and Rocket Chat, and on IRC as well if you're old school and use IRC too. If you enjoyed this, leave a comment, let me know. If you want more of these kind of tutorial type things, then we can do that. We'll be back next week, I think, with probably Sergio and Leo, maybe reporting on the fun they've had at UbuCon LA. If you want to subscribe to the channel, it's youtube.com/snapcraft.io, and also follow us on Twitter and all the usual places. We're Snapcraft.io, basically everywhere. So thanks for watching, and have a good weekend, and I'll see you next time. Cheerio, everyone.